here the problem is to find the best set of items that a group of users appreciate together. So here the challenge is that each individual can have different preferences. It becomes even more challenging if we consider some affinities between users. What if Jacob and Julia are married and they influence each other, the preference of each other more than Olivia? So here our problem that we address is group recommendation in presence of temporal affinities. So user group recommendation has received lots of attention in the literature in different domains, like in news pages, in tourism, in music, and etc. So there exist two dominant strategies for user group recommendations. The first one considers a pseudo-users for the group of users and try to recommend to these pseudo-users using classical recommendation algorithms. The second strategy tries to aggregate preferences of members of the group to obtain the preference of the whole group. Our approach is considers the second strategy. Also, Coren has proposed for the first time the temporal dimension in group recommendation by the intuition that people change their preferences, their ideas in time. So what we consider as the problem is, again, the group recommendations considering affinities, which evolves over time. So for that, we need to revisit the group recommendation components already mentioned in the state of the art. So we already have absolute preference, which simply means how much user U appreciates item I. Now we add relative preference, which means how much user U appreciates item I in presence of other members of the group G in the temporal period P. But how do we capture affinity? Affinity is captured by two different components. We consider a static affinity, which is static over time, doesn't change over time, like the difference for a pair of users, the difference in their age, the difference in their level of study, the geographical distance between their birth locations. We also consider dynamic affinity, the component which evolves over time, like the movie tastes, the political views, and others. So affinity is calculated as a linear or exponential aggregation of these two components, static and dynamic affinities. So now, based on these definitions that we provided, we can formally define the group recommendation problem. Given a user group G, the problem is to return k-best items to recommend, we denote it as IG, during period P, such that this IG contains k items. And every item in IJ is new to all members in the group. And there is not any other item outside IG that has a higher score for members of G. So for this problem, we propose an algorithm which is a Fagan-style algorithm, like NRA in the state of the art, which exploits the monotonicity property of aggregation functions for earliest stopping and preventing the exhaustive search. So this algorithm has three main steps. In the first step, it materializes following lists: static affinities for each users, absolute preference list for each users, and dynamic affinity for each users and in each period. So once these lists are materialized, the algorithm starts making scans in sequential order in a round-robin fashion. And in each scan, it receives either an item or a users with a score. And using them, it tries to add the item to the buffer, or if it is already added, update its lower and upper bounds in the buffer. And now the last question is, where does the algorithm terminate? So the algorithm terminates if the lower bound of the kth item is bigger than the maximum upper bound of all other items in the buffer. So if it is the actual case of the buffer and k is equal to 1, the lower bound of the kth item is 3.2. The maximum upper bound for all other items is 3.1. So we can safely stop because we are sure that there is no other items to be introduced in the future to be inside k items. So to validate this algorithm, we have made some experiments. So for the experiments, we build a Facebook API, and using that, we ask participants to build their profiles by rating 3 to 15 movies from MovieLens, and then also invite 10 to 20 of their friends. So using this data that we collected, we can define our affinity components that we already mentioned. So for a static affinity, for example, we can consider the number of mutual friends for a pair of users because it's somehow static over time. And for dynamic affinity, we can consider the number of common page likes between a pair of users. For example, if a pair of users has liked many music pages in the first period, but in the second period, they don't have that much common page likes, so it means that in the first period, they had more affinity. So based on this data, we formed some groups based on parameters in the literature which play a role in the satisfaction of users. For example, we consider a group size that could be small or large. Small contains 3 users, large contains 6 users. We considered group cohesiveness, which we have groups which contain similar users or groups containing dissimilar users. And we also considered affinity strength, which we consider groups whose users have low affinity and also high affinity. And here are the percentage of their preferences aggregated for each group. For using affinity and also here using time. So here, for example, for similar groups, they mentioned that they preferred in more than 75% of cases results obtained by using affinity to results without affinity. So also in this case, we observed that almost all, for all groups with any characteristics, users prefer results using time comparing to results without using time in more than 75% of cases. We also observed that in case of using affinity, small groups and high affinity groups benefit the most from using affinity. And this is mainly because in these groups, members know each other, and in this case, affinity can affect more, can influence more this group.